Well, so good morning, everyone. We are team en3b, composed by Miguel, Carmen, Álvaro, Juan, and Marcos. And today we are going to present our project, Radarin, which is a web and mobile application for meeting with your friends on the street. Sorry. The concept might be simple, but Radarin is much more than that. In our opinion, a web application was not usable enough, and that's why we created a simple, accessible, and portable mobile application. Nonetheless, oh, sorry. Nonetheless, we do not expect all of our users to have a laptop or a desktop for using the web application. Hence, it is fully adaptable to mobile as well. Then the functionality is also divided. The user would periodically send his current location from his mobile, as well as creating markers with the title, description, and even a photo of his current location. He could also see which of his friends are near him and even go to their location with the help of Google Maps. From the web application, the user could see both the created location by himself and the friends in a map. He could also see the path that he took on any previous day that would be also displayed on the map in the form of a polyline. Well, now let's move on to the quality attributes. While developing this project, we tried to keep ourselves loyal to the quality goals we established at the beginning of it. Our top priorities were usability, privacy, security, and portability. For usability, we kept in mind that at all moments, that simplicity is normally better, trying to respect how things are normally done or shown, and inspiring our designs on the greatest, like Google or Amazon. But adapting to our needs, we also tried to think as a new user when interface decisions had to be made, even asking less technical people from our friends and family to make sure they could understand how it worked. Privacy is also fundamental on this project, and that's why the only centralized information that the application has is the location of the users, information that we decided that couldn't be safe on the pod, as the access as a frequent access would lead to performance problems. But even in this case, the only thing that connects the location to the users is their public web ID. About the user's friends, it is important to note that whenever we show something to the friends of a user, we make sure that the friendship is mutual. That is, both persons have the other person as a friend in the pod. That avoids the possibility of a user adding someone as a friend and seeing their information without any other person approval. And although the location that the user decides to post are public, he or she has total control of them and as they are stored on the pod, so they can be removed whenever the user decides. We also try to contribute to what we thought that could be useful for the community. Writing the application, we found that there was no library implementing JSON Web Token, signing in an asymmetric algorithm RS-256. We learned how the JSON Web Token standard worked profoundly and implemented it from scratch with only a crypto library. And then, as it could be useful for other people, we publish it at npm. And security is going to be explained later in the keyword section. Last but not least, we have portability and compatibility. The web application is fully portable and available on every browser. The mobile app can only be used on Android phones, supporting by the most common Android versions nowadays. We were able to check its correct behavior on Android 7, 9, and 10, although at the end, the Android 10 version gave us some problems as the library we use for the location had a bug, and it is already known and has an official issue on GitHub. But it should work fine in recent Android versions. We would have liked to make it portable to iOS, but time was a scarce resource on this project, and thus we decided to center our efforts on Android development.
Okay, so now I will talk about the architecture. The architecture, sorry, yeah. The architecture of our application has four main components: the web and mobile applications, the REST API, and the database. It is worth mentioning other important components that are not ours but play a fundamental role in the functioning of the application, like the ID provider and the pod hosting. The web and mobile application retrieves the user's location from the database through calls to the API. At the same time, the user retrieve and modify the created locations from the pod, which they have access thanks to the credentials obtained from the ID provider. The information is stored locally using Redux for increasing performance. These components interact with each other constantly, and that is why we will explain some cases for better understanding the bigger picture. The first one is how the mobile checks for close friends. The phone app would periodically request the locations of the user's friends to the API, like this. And the API would request the user's friend from the pod and then go to the pod for checking that the friendship is mutual. Once that is checked, the API fetches from the database the locations from the friends and returns that to the mobile app. That then would calculate distances and show the friends appropriately. Then we have another map for how the created locations are stored. First, the user would put a title and a description from the mobile application, and when he presses send, an embedded browser would open that would ask him to log in. The value of the title, description, and the current coordinates of the users are passed to the web app as get parameters. After the user logs in on the web app, he can add a photo if he likes, and then the location would be saved onto the pod. And then, while the pod would notify the success, the web app to the user. And last, we have how the locations are fetched from the user and stored in the database. Once the user logs in, he gets a private key. The mobile application would send the location sign with the private key that it uses as verification. The process of verification and how the keys are generated will be explained later. Once the API knows that the petition is valid, it will store the location in the database. Well, this is all the process of asking for the keys and how it stores the location in the database. We use a QR for login into the mobile application, but that process will explain later. Even if its functioning is important for the architecture of the application, we see it more as a solution strategy that led to an architectural change. So now we will start already with our solution strategies.
You're muted, Álvaro. Álvaro.
Sorry?
I think he's muted.
Okay, sorry. I'm going to start again. I was talking. Okay, our approach for the frontend was to use React Redux on the web application and React Native Redux on the mobile one. This makes working on any point of the application to be very similar, allowing us to move and develop features without needing to worry about differences in implementation or programming languages. We are going to go a little deeper on Redux, since it helps us greatly. As we were developing the application, we found ourselves in places where we needed to share information where components that were not Fairchild. Information passing through the React component chain is difficult, especially if some components are functional and other class-based. We found Redux to be a perfect solution for our problem, as it basically is a store where the state of the application is saved, and can be updated and retrieved from any point in the application. Redux is implemented both in the mobile and the web. It especially helped us with locations, which are an essential part of our applications. Locations are listed in a view with the map, but they are different components. When a location is clicked, we want the map to display these coordinates. Redux helped us to make it. Basically, instead of passing the coordinates through every component until we reach the map, we can store them in the store, and the map will be retrieving the most recent value. Other users of the slice. When we fetch the location from the path, they must be stored somewhere. In addition, the view must wait for the fetch to finish before trying to show the location. With the help of async thumbs and Redux, we are able to do this. This way, we convert what would be an async call to a fetch method, to a dispatch which is synchronous. Then the thunk will be in charge of waiting for the locations to end. This thunk itself is a promise, with 3 status: pending, rejected, and fulfilled. The state of the promise can be stored in Redux, which allows us to spy from it on the component. This way, in the process, we can display a loading symbol and show the locations where it ends. As before, the status is in the store, so it will update the component each time it changes, avoiding having to check periodically or manually. Redux introduced us to hooks and the power, and that is why we decided to change every single component into a functional one. Okay, yes, using React Native for the mobile application was a risky play, but we didn't notice until it was too late. One of the main disadvantages of native is that it doesn't work with a document object model. So every React library that uses DOM does not work on native. The real problem was logging into the path. We could not use the in-group libraries, and there doesn't exist a React counterpart. At this point, we had 2 options: drop all the work done in native and do one application, or do the logging manually with fetches. We didn't want to drop native, as it was a right decision usability-wise, but implementing the logging was too much work, and we were not sure that we could make it work. Luckily, we came up with a solution, as at the moment the mobile didn't need the pod, we could work around it. But the problem with this was requests to the API. We needed those requests to be authorized, and in the web application we could use the in-group session for that. In the end, we decided to use a QR code login for the mobile, as the one that you will find on WhatsApp web, just reversed. Although this process is already described in this slide, maybe it is easier to see with an schema. Okay. So the idea is we generate a QR code from the web application. This generates a pair of keys that we store in the path. The public key is stored in a public folder and the private in a private one. Then the user will scan the QR code from his mobile, which contains his web ID and the private key. This information is stored in a private store on the user's mobile, and is valid until the QR code is manually changed by him on the web location. Then, now each time the user wants to send a location or to get the location of his host friends, we can verify the user's identity from the API. This prevents anyone from making a request to an endpoint and getting the location to everyone. The API receives a list of web IDs of the friends we want to get their location in a JSON web token signed with the user private key. Okay. This way, the API can later decipher the message with the public key of the user, which it has access to since it is in a public location on the user spot. The API also knows the user web ID as it is sent along the request. The security almost implements by itself, as if the user manually changes the QR code in the web page, the request to the API from the mobile now is unauthorized. This way, we can catch the exception, meaning that the session expired, and ask the user for scanning the new QR that must have been generated. This approach worked fine until we needed to create location with the name, description, and photo from the mobile. This required us to have real access to their pod, so our workaround this time was to use an embedded browser.
Okay, so now I'm going to talk about a bit about testing and documentation. And first of all, we have three types of testing developed which was end-to-end test, load test, and unitary tests. The end-to-end test builds the whole application and then run the tests, but using Jest and Cucumber did not allow us to have it until the view changed. So this is why we did not use them extensively. Another reason was they were not really reliable for some reason, and they could work in one commit and then and fail on the next one without having changed anything. Even if we increased the timeout, this kept happening. So we did some basic test with end-to-end and then moved on. Now let's talk about the unitary testing. We took this test very seriously, as we believe they are very important to keep the application in a consistent state. And we did not work with test-driven development, but with domain-driven development. But nonetheless, every feature is tested to ensure their correct functioning and for assuring that new changes do not break the application. At the beginning, we did not know much about testing a user interface with Jest. So we tried to simulate what a real user will do. This implies that we did not mock anything. We found a library for logging into Solid from both a script called Solid non-client, and that used a generate OYDC token for getting our credentials. A bug was found on this library and posted on the Solid forum. One of the collaborators was able to replicate the error and opened an issue regarding it, and another kind collaborator gave us a possible workaround to that issue, and that worked perfectly. After this first approach to testing to get proficient and learn how to mock function, this allowed us to test much more in depth, mocking every single Solid function and writing complicated conditionals that only were executed in precise cases. We did 4 load tests. The first 2 were based on logging in, going to the map, moving around, generating another QR, and close session. It was an especially heavy test, as the map especially requires a lot of picture requests. First, we tried with 20 users per second for a minute, but it didn't go so well. So in the end, we reduced the number for 2 users per second, and we could see some interesting things. 90% of the petitions that failed were related to the pod browser. On the remaining, we have some requests from the Roboto font to Google failing, probably due to them blocking us for a possible DDoS attack. And some of TSS failed as well because Chrome decided so. The remaining 5% were API failures that looks like they were due to the login request failing, thus the API throws unauthorized responses. Then we did a load test that consisted in logging in and going to the map without moving the map, then navigating to the about page and logging out. Same settings as before, 2 users per second for a minute, and this test will be seen to have the same ratio as in the previous one, but lower, as here we can see, as the less requests were made. And thanks to the testing, we achieved a code coverage of 100% on the REST API, and 91 on the web application. We can see here the results of the test of the web app, which were 61, and the REST API, which were 23. And now I'm going to talk about the documentation. In fact, we put a lot of work on the documentation from the beginning, and this was incredibly helpful during the development, because it helped us to get a clear concept of the scope of the project and the parts that formed it. And it also allowed us to plan things in long term and quickly see if there were going to be some problems along the way with the decision we wanted to make. It helped us to understand the technologies that we were going to use and how the system was supposed to work. And this allowed us to distribute work correctly and, more importantly, estimating the time that each part of the documentation will take. Of course, the first draft is not enough. That is why we took care of updating periodically and making it match with the current state of the application. This was not very complicated, since the original idea was pretty spot on, so we did not have to make major changes to it. Regarding the documentation of the REST API, since it was probably the most complex part of the system, we decided to use Swagger for documenting and it in an interactive way. Basically, you could test the API against the real one that is deployed in Heroku, just as if you were a user using the application, a real user.
Okay, let me take it from here, Juan.
Okay.
So we are a little bit short on time, so I will talk about the future quickly. We had some bugs, especially on the mobile side of the application. The embedded browser was not inside the mobile phone when you went to recent apps. So sometimes when you want to upload a photo from the camera, you got back to the application instead of the embedded browser. We mentioned earlier, Android 11 is not compatible because of some bugs that are officially in an issue in Expo. And well, we would love to do iOS support, as it will only require some changes on the permissions and sorting the locations, as right now they are shown on the map. Together the polylines with the store locations, and well, if a user have a lot of them, it could be confusing. And while testing the mobile, we were completely unable to do so. We tried a couple of times, but with no luck. So we would like to see if we can do something about that, because it's completely necessary. And well, now we will show you a demo of how the application works. So please, Carmen, share your screen. Okay, so we have prepared a pod, more or less. He has two friends. One is me, which I haven't sent locations in a while, so I will appear as disconnected, and the other friend is one who is near. And right now, this demo test, we simulate that it hasn't used the application ever. It could be what a new user would see for the first time. So Carmen is going to log in with this test pod. You could see the sign-in page. You could choose the provider you want. We have right now Inrupt and Solid community for choosing. And once you sign in, you will be redirected to the Inrupt login page, where you could search your credentials. And well, basically, we will try to show the mobile and the web application at the same time, as to prove that each time you upload, well, each time we fetch a location from the mobile, the polyline of the path that you took, in this case today, is updated in real time. The same with uploaded locations and the ones of your friends. One thing to remark is that we do not consider that a user is using the application until he sends at least one location from his mobile phone. So right now, as the user didn't send any. If Carmen goes to the locations view right now, you could see that a message could appear that please send some locations first before entering this view. That's it. So right now, please Carmen log in from, well, first, for logging into the mobile, as we mentioned, we need to generate a QR that you could access it from there. You click on your name and then on QR. This will generate a QR once the pair key is generated. There it is. And now Carmen is going to scan it from the login page of the mobile. We try to keep a little bit of the context of the application, colors, and that thing between the mobile and the phone, the mobile and the web application. And well, the first time you log in, you will be shown a help in case you are lost or you don't know how to use the application, with some interesting and useful photos. You could access this anytime from the About page in case you want to see them again. And in this case, we can see that me and Juan are far. This is because, well, the user right now, the first time that he accessed the mobile, has not the location activated, as it's something that we want to leave the user to decide. So Carmen is going to go to the profile page and activate the location. So if you excuse me 1 second, my webcam, I need to use the mobile. So once she activates the location, you can go back to the main profile, and supposedly Juan, in the next refresh, Juan is going to appear as close. He is close. If not, I'm going to be close right now because I just sent a location. Okay. So if you go to the locations tab in the web application, you could now see in the next refresh should appear in this case your friend locations, as now you are a user. Well, also important to mention that the session is restored each time you press the page and you're sent back to the place you were before. And there it is. We can see the legend of the map, the friend's location, your location, and selected locations. In this case, we can see there is one of my locations in my flat. So please, Carmen, if you could open that location. Yeah, you can open through the marker, or if you want to see the photo, you can click on open. Then you can see all your friends, and at the bottom you can see that says route taken on this day, and in this case is the locations that Carmen is sending right now in the form of a polyline, as she is still only a dot is showing. So for example, Carmen, please create a location from the mobile phone. Here's the ad. There is a tutorial the first time. Okay, you can write a title and a comment on the location that you want to send. And once you press send location, the embedded browser that we mentioned earlier is going to be opened. In this case, it's not embedded for some reason, but well, you are redirected to a web application and you can sign in. So you have to repeat the process. This is mainly because if you retrieve the location once you refresh the page, you will be redirected with different get parameters, and since that is how we choose to do it, we don't have other option but to ask you to log in each time you want to upload a location. So later, when Carmen uploads the location, she can upload a photo if she wants to, and we will see it update on real time on the location list. And in this case, as the location created is going to be yours, you have the rights to delete it if you want to. So there it is, the title and the description. So please add a photo. And well, this procedure of adding a photo crashes in some devices because of what I mentioned earlier that we want to fix. So now Carmen press send, you wait a little bit for the for the location to upload, and then you can close the browser. Okay, and well, while the location updates on the web application, Carmen, please show the about page of the mobile phone. Well, there it is. As you've seen, now hello is a location on the web. You can open it. You can see the photo that Carmen just took, and you can remove it. Please remove it. Okay, and it should gone from the list. Okay, it's gone. Okay, so go to about page, please. It's pretty much the same as in the mobile, and then to the help page. Okay, here you can click on different points to see information about what each does. For example, click one, click on locations, whatever. Yeah, okay. And well, you can also see a tour with clicking on the button Open Tour, and this will take a little tour on the different parts of the app. Okay, go forward till the end, and yeah, forward. And here you can close it, and the application will refresh because the library that we use for the tour will crash the application if we don't refresh. And well, for the last part of the administrator, Carmen is going to log in with two users. One is going to be the administrator, and one is going to be a user that we use just to block him. And we can see that the blocking process is updated on real time. Once you're blocked, you won't be able to use any locations, as you will be marked as unauthorized to any petition to the REST API. This message that you are blocked is going to be shown in the locations list, and the mobile phone will just not work at all. Well, the admin has the ability to block and unblock all the users. Each time he blocks a user, the icon will change to show him that the user has correctly been blocked. And for adding administrators is only possible through MongoDB hardcoding it, because we thought that it would be a security issue doing it otherwise. So as the administrator, you could see another tab in the app that would be admin, that should not be unauthorized. Okay, this is the correct view. Here you can see all the users, and for example, show the other screen at the same time if you can, please, Carmen. Go to the locations tab with the user to block. Okay, the user to block right now is not blocked, so he can see his root, and if Carmen blocks him from the admin, okay, the admin would see that the user is blocked, and the user to block in the next retrieval of the locations from the pod or the API, the petition would be unauthorized, so automatically a message of not authorized will be shown in the locations view. It takes a little bit to show this. There it is. And if Carmen unblocks the user now, it could be back to normal. The refreshes are done in the mobile phone for checking that your friends are near each 10 seconds, and on the web application each 30 seconds. And then, well, as this happened, Carmen, please show the video of the notifications. That is the only thing that we cannot show you, as the library that we use for implementing notifications on the mobile application sends them quite randomly, but well, it works. On some versions of Android, we still need to fix them for working on every single version. So yeah, hit play. You can see I have two accounts there. The one with my name separated is far. So right now I would be sending one location, and well, you can skip the video a little bit, Carmen, because this is too long. Basically, Carmen is waiting, and practically at the end, a notification will be shown that you have new friends near you, and once you open the application, you could see that my profile will be indeed near. There it is, a notification. Click it to access the application, and there you are. Live together, that's why I appear as 0 meters. And that's all. Thank you for listening. now is time for questions. I can share
Okay.
the presentation again.
I am stopping the recording.